So I'm Taylor Marchment. I'm from Swinburne University of Technology, and my presentation is on 3D concrete printing, a rapid housing solution. We are in the midst of a housing crisis where 1.6 billion people currently live without adequate shelter. 1 billion of those live in slum-like conditions, where people are forced to live in overcrowded makeshift shacks squashed together between rubbish and dirt. These shelters are unstable and unable to resist wind, heat, rain, with little to no windows or ventilations. By 2030, it is estimated that 1 in 4 people globally will be living in these such conditions. But why? Well, one major reason is that conventional construction methods are slow, dangerous, costly, and overall labour intensive. They just simply can't provide housing at the rate that the population demands. This is the same issue that is faced when rebuilding homes lost to wars and natural disasters. But what if all it took was to deploy a robot and at the push of a button, a house was built within a day? It'd be like something out of a sci-fi movie, right? Well, this is the basis for construction scale 3D concrete printing. You see, a semi-solid concrete mixture is squeezed out layer by layer, allowing it to be built up in any formation directly where the structure is to be located. No molds, no supports, just concrete. But you see, it's not just that simple. As the concrete needs to be stiff in order to be stacked layer upon layer, a critical issue arises. Between these layers are weak points, and they are brittle. This compromises the strength of the entire structure, making it susceptible to premature collapse. In my PhD, I've developed a technology to create continuity between these layers. I've developed an attachment that fits where the concrete is squeezed out, and simultaneously strips of reinforcing mesh and bar are inserted and embedded within each concrete layer. This ties together the entire structure, kind of like forming a continuous internal skeleton. Lab tests have shown that this increases strength by up to 180%, and the brittleness is significantly reduced, allowing a greater degree of bendability before collapse. Not only making these structures stronger, but safer. And I think it is safe to say that we are now not only one step closer to providing 1.6 billion people adequate shelter, but a home.